All right, here we go. So I'll go over this real quick. We've got the top row times the first column. Also noting first that we can do this. This is a 2 by 2 and this is a 2 by 1. So since these inner numbers are the same, we're good. The outer numbers tell us what kind of matrix we're going to get, which is a 2 by 1. So at the end, it's going to look like this with just kind of that size matrix. Okay, so 2 times 4 gives us 8, plus -3 times -2, which is 6. So that gives us 14 for the top number. And then the bottom number will be 1 times 4 plus 0 times -2, which is just 4. So if you got the matrix 14, 4, you are correct. If you did not, hopefully you saw kind of what happened there, how we got 14 and how we got 4. Okay, so today's lesson is still in 6.1. This is actually the true book 6.1. So the other stuff was kind of a mix of 6.2 and then some previous things that you would need kind of before you get to 6.1. This is going to be the real 6.1 that's the same as in the textbook. So we're going to be talking about systems of equations and matrices. Okay, and so today we're going to go over kind of 3 main things. First one is putting a system of equations into something called an augmented matrix. The second thing is we're going to be able to identify something called row echelon form and reduced row echelon form. And the abbreviation for this, which is REF and RREF, since we don't have to go around writing row echelon and reduced row echelon all the time. And then the third thing, use reduced row echelon form to solve systems. Okay, so that's where we're going today. Now let's talk about some of this vocab. So first, hopefully we remember what a system of equations is. If we don't, we'll take a look at that real quick. Systems of equations. So you might have seen in algebra or advanced algebra, but most likely regular algebra, 5x plus 3y equals -31. 4x plus 2y equals -22. Systems of equations that look like that, where you have to solve it using elimination or substitution or something like that, right? So the algebra way of solving this would involve, you know, either like subtracting the rows and stuff like that, you know, subtracting the 2 equations or adding the equations or, you know, things like that to try and manipulate it into getting x and y by itself, right? So the thing is, people realize that if you took just the numbers out of here and got rid of the x and the y and the plus and the equals and everything and stuck it into a matrix, that you could do pretty much the same thing, except one, it looked a little bit neater. And it was sometimes a little bit easier to keep track of. And 2, it was easier to stick it into a calculator. So that's where we get, so we used to use, you know, like elimination and substitution are the ways we know. Now we're going to do it the matrix way. And we're going to use something called an augmented matrix. So that's just the matrix that you take all of the coefficients and everything and put it into. So my augmented matrix looks like this for this particular set of equations. We'd get 5, 3, 4, 2. And then it's augmented with -31 and -22. So this is the augmented part. So you basically put the coefficients into a matrix with the constants in a column on the far right. Okay. So we're going to be able to do something with this matrix that really resembles elimination. But before we can start doing that, we need to kind of talk about a few vocab words that will help us figure out what it is that we're looking for. What we want our augmented matrix to end up looking like to get an answer out of it. So the first thing we need to talk about is row echelon form. Okay. So some possible ways that row echelon form could look is where we have ones along the main diagonal, and then a 0 in the bottom corner, and then some other number right here. And then in the augmented part, other numbers here. So A, B, C could be any number, but the rest of the matrix, if it's a system that looks like this, needs to be ones and a 0. Or if you had a 3x3, if you have 3 equations and 3 variables, your row echelon form will look like this, where you've got the ones along the main diagonal, you have zeros in the corner, and then you have whatever other numbers, D, E, F, elsewhere. So this is what row echelon form looks like. And the reason that it's helpful is if I can get this matrix to look like this, then I can take it back out and make it into equations again, and I can solve it really easily. But there's an even simpler way than row echelon form that will tell you what the answer is directly from the matrix. So this is called reduced row echelon form. And reduced row echelon form is very similar to row echelon form, except for one main difference. The value that's A, some random number here, or A, B, and C right here, those will all be zeros in reduced row echelon form. So we would have 1, 0, 0. So it's an identity matrix here. And then the value for X and the value for Y would be in the augmented part. And it's the same idea if you had a 3x3. You have the 3x3 identity matrix. And then you have the values for X, Y, and Z in the right-hand column in that augmented part. Okay. So our goal with our augmented matrix is to make it look like reduced row echelon form. Or row echelon form, but then you have to do a little extra step. So usually you want reduced row echelon form in order to solve it. Okay. So with this, you can find reduced row echelon form by hand. And I will show an example of finding it by hand, but then I'll show us something that's going to make our life a lot easier. So with the example by hand, do your best to follow along. They're kind of like little puzzles. And I kind of think it's called the process of row reducing. I think row reducing is kind of satisfying. But if you have a 3x3 matrix, it can be very time consuming. So I will show us an easier way once I show you the long way. Okay, so we're going to take this matrix and we're going to use this one for our example, the augmented matrix that we had from this particular system of equations. So row reducing. So this process of row reducing is what we're doing right now. So we start with our matrix 5, 4, 3, 2, -31, -22. And what we can do is I can take rows and subtract them from one another. I can take rows and divide the entire row by the same number. I can change the order of rows and things like that. I just can't change the order of columns or do anything to the columns. That's why it's called row reducing, because we're only manipulating the rows. And if I do something to a row, I have to do it to the entire row. Okay, so here we go. I'm going to start by saying that this top row is row 1, the bottom row is row 2. I'm going to abbreviate with R1 and R2. And I'm going to show my steps in this way. So our goal, keep in mind, is to get a matrix that looks like this with some other numbers over here, some number X and some number Y over here. So that's our goal. So just looking at this matrix, one thing that I notice is that 5 minus 4 is 1. And I want to have a 1 in that top corner. So I'm going to take row 1 and subtract away row 2. So I would go 5 minus 4, which is 1. 3 minus 2, which is also 1. -31 minus -22, which is -9. When you're dealing with negatives in here, it's really easy to get tripped up as well. So you want to make sure that you're, if you were to do this by hand, that you either use a calculator to double check yourself or make sure you're 100% sure of your answer. Okay, and then row 2 is just going to stay the same for this step. So 4, 2, -22. Didn't touch row 2 at all. Okay. So far so good. We've got the 1 in the top left corner that we wanted. Now we're going to keep going and try to get something else out of this. So now I want this to be a 0. So I'm going to take row 2 and I'm going to subtract away 4 times row 1. Because 1 times 4 is 4. And if I subtract away 4 of them, that will get me a 0 right here. So we have 1, 1, -9. That top row stays the same. I'm not touching it. But this one, I have to go, okay, row 2 is 4 minus 4 times 1, which is 0. 2 minus 4 times 1, which is -2. -22 minus 4 times -9, which gives me, let's see, 4 times -9 would be -36. Minus a negative, that would give me +14. Okay. So far, so good. We've got these two things that we wanted. Now all that we have to do is make this into a 1 and this into a 0. I'm going to start here. I'm going to take this bottom row here, so row 2, and I'm going to divide it by -2 so that I can turn this into a 1. So I'm going to take the entire row, the top row staying the same, but the bottom row, 0 divided by -2 is 0. -2 divided by -2 is 1. 14 divided by -2 is -7. All right, we're really close. Now all we have to do is make this into a 0. And to do that, I can just take row 1 minus row 2. So that will give us 1 minus 0 is 1. 1 minus 1 is 0. -9 minus -7 is -2. And then we're leaving the bottom row the same. Okay. So now we have something that looks like our goal here. So we're done. And what this tells me is that x equals -2 and y equals -7. And that is the solution to our system of equations. Okay. So there's some parallels here between this and doing elimination. If I was going to do elimination here, the first thing I would probably do is take this equation and subtract this one, right? So that I could get 1x plus 1y equals -9. That's exactly what we did in our first step here. We just did it within a matrix. So it's very similar to elimination. It's just a little bit cleaner of a process, and the numbers are a little bit easier to keep track of sometimes, or some people feel that way. Okay. But again, this was quite a process, 1. And 2, if you had 3 equations and 3 variables, this process would likely take a lot longer. So luckily there's calculators. Luckily those are a thing. So luckily calculators exist. Now there's 2 different kinds of calculators that can do this. So all of you out in Google Meetville, type in the chat, does anyone have a TI-84 graphing calculator or something similar? Does anyone have like a physical graphing calculator? Okay, awesome. Looks like a lot of us have them. If you have one, go get it real quick. If it's nearby, go get it. I'm going to show you how to do it on a TI-84, and then I'll show you how to deal with it on a Desmos. So I've got my TI-84 here. And we're going to make the calculator do exactly what I just did. Okay. So if you've got your TI-84 with you, the first thing that you want to do is hit second matrix. Okay. Then you want to go over to edit, and under matrix A, hit enter. I've already put in this matrix that we've been using, but if you're just putting it in for the first time, or you're putting a matrix in your calculator for the first time, you want to change the dimensions up here. So we want a 2 by 3 in order to accommodate what we've got going here. So type in 2 and 3, and then come down here. And then you can just type in, okay, 5, and then if you hit enter, and then 3, enter, -31, enter, 4, enter, 2, enter, -22, enter. Okay. So now you've got a matrix. Type done if you're doing it this way. Type done in the chat once you've got your matrix entered. Yeah. So the beginning is just hit second, and then matrix. It should be, it's a secondary function on the x to the -1. So second matrix. And then hit the over arrow until you get to edit, and hit enter on edit. And then type in your dimensions. We want a 2x3 for this one. And then go down into the matrix and enter your numbers. All right. So now we've hopefully all got our matrices, anyone who's doing it on a TI-84. So then you can hit second matrix again. This time we're going to go to math. So there's all these different matrix functions that it's got under here. Some of them you will use in this class, some of them you will not use in this class. If you go down to the one that says RREF, it should be B. Once you get to RREF, hit enter. Oops, sorry guys, never mind. You have to quit that matrix first. So sorry, hit second quit. And then go second matrix, math, RREF. Then we're going to call up that matrix. So we're going to go second matrix again. And under names, you want the matrix that you just edited. So if you did matrix A, all you have to do is hit enter. And then hit enter again. And it brings up the reduced row echelon form for that matrix. So instead of doing all the work of row reducing, it can row reduce your matrix for you. If you just wanted reduced echelon form, if you went second matrix under math, that's just reduced echelon form. If you go to edit, and let's say we wanted to put in a different matrix. Let's say I wanted to edit matrix B and make it a 2x3 as well. And let's say I did 2, 3, 5, 9, negative 23, 36. And second quit. I could call up my matrices. Oops. I can go A minus B, and it would subtract my matrices for me. So you can add, subtract, multiply, divide. You can do all those operations with matrices within a calculator. You can do reduced echelon form. You can use that to solve your systems of equations and things, all within a calculator. Okay. If you are going to be working with a Desmos, type Desmos in the chat if you plan to use Desmos. All right, we got several of us using the Desmos today. So yeah, if you're using Desmos for now, that's cool. If you are planning to take AP Calculus or AP Statistics, you're going to want a TI calculator. You can borrow them from the school and the library when you take those classes, or you can purchase your very own. But let's jump over to a Desmos. There's something called Desmos Matrix. So if you go to Google and you type in Desmos Matrix, I'll post a link in Classroom at some point. That was my dog. Okay, Desmos Matrix. Click on that first link that comes up, and this should pop up for you. Okay. So Desmos came up with this wonderful matrix tool, and all you have to do to put a matrix in is click New Matrix. You can edit the rows and columns. So if I wanted to make it a 2x3, all I have to do is add a column. And then you can do exactly what we did in the TI-84. You can put in your matrix 5, 3, negative 31, negative 22, 2, 4. And then once you're done with your new matrix, you just hit enter, and it saves your matrix. Then you just do the same exact thing that we did in the TI calculator. You can click RREF and matrix A. And lo and behold, There it is. Or let's say I wanted to multiply some matrices. So let's go make a new matrix. 2, 3, 4, 5, 6. Enter. And let's do A times B. And it tells you what those matrices would be multiplied. It also tells you, like, let's say I made a new matrix 2 and a bunch of zeros. Great. Let's say I try to do A times C. And then it tells you, hey, you can't do this because your matrices don't have compatible dimensions. That's undefined. Okay. So these calculators can do all of the things that we've been doing this week, and they can do even more than that. They can row reduce your matrix for you. Okay. So let's see. Let's try a few examples. You can use whichever calculator you're comfortable using. We're going to do some examples that involve longer equations. So here we go. We are going to do, first of all, negative 3x plus y plus 6z equals 15. 2y plus 2x minus 5z equals 9. And 2z plus 4x minus 5y equals negative 3. Okay, and so the first thing that we have to be able to do is correctly put this into an augmented matrix. So let's go ahead and, where'd my other color? There it is. Okay, when we put things into an augmented matrix, be careful that you're putting the same variable in the first column, things with this next variable in the second column, and things with the third variable in the third column. So I couldn't just put negative 3, 2, 2 in this column because we have an x, a y, and a z. So if it helps you to rearrange it first, you can. We need to make sure the x's go in the first column, the y's go in the second column, and the z's go in the third column. So negative 3, 2, and 4 would go in that first column because those are the x coefficients. If it helps, you can put an x there to remind you. Then the y coefficients would come next. So we have 1, 2, negative 5. And then the z coefficients, we would have 6, negative 5, 2. And then we augment it with 15, 9, negative 3. Okay. So if we were asked to just write an augmented matrix for that system, there it is. If we were asked to go the other direction, if we were going to write the system that comes from this augmented matrix, you would just go negative 3x plus y plus 6z equals 15, 2x plus 2y minus 5z equals 9, 4x minus 5y plus 2z equals negative 3. So you can go back and forth. Okay, so now using whatever calculator device you would like, type in this matrix and find the reduced row echelon form. So I'm going to go with the TI calculator for now. If you want to use the Desmos, you are welcome to. Okay. Once you've got your your reduced row echelon form matrix, go ahead and write that down in your notes. Anyone having calculator troubles at all out there? Any questions with the calculator? All right, are you using the Desmos, Jasmine? All right, I'll jump over and do it on the Desmos as well. So I'll just clear everything. RREF is not showing on Desmos. Let me see. Here, I'm going to post the link that I'm at in Classroom real quick. So make sure, first of all, that you're at this Desmos. And then what you want to do is click New Matrix. And then for this one, since I'm putting in a 3x4 matrix, there's 3 rows and 4 columns. So we want to change our rows and columns. And then we want to put in our numbers. So we've got -3 in the top row, 1, 6, 15. So is everybody at our, let's see, Paige, Jasmine, are you guys at this point so far? Not yet? Okay, I'll wait a sec. So first step was click New Matrix and then change your rows and columns. Okay. And then we'll keep typing in the rest of our numbers. So we had 2, 2, -5, 9. And then 4, -5, 2, -3. That's what our matrix should look like. And then once you do that, once you type your last number, hit enter. That should make all of the buttons pop up again. Benny, are you able to get the RREF now on Desmos? Okay, yeah. So just pretend that the dotted line's not there, if that helps. The 15, the 9, and the -3, that just goes in the same matrix, just in the far right column. Cool. And then you can just go RREF, matrix A. And that's what we should end up with. Okay. Yeah, and this is all brand new calculator operations, so it's normal to get a little bit confused with these at first. Are there any questions remaining out there about the calculators? Anything that we're not able to find? Numbers we're not sure where they came from or where they're going? Okay. Then back to the paper. This should be the row reduced echelon form of our matrix. And so we need to figure out what this is going to tell us. So what it tells us, X is always the top row, Y is the middle row, and Z is the bottom row, as long as you made, the X column, the Y column, and the Z column in this fashion. Because what this is really telling us is that 1x equals 8. 1y, since y is the middle column, equals 9. And 1z, since z is the third column, equals 5. So our solution to the system would be that. Okay. Let's try another one. I'm going to have you guys do this one. So I'm going to give us a system here. We'll do 5x plus z minus 50y equals 24. And 10y plus 2x plus 3z equals 23. Yes, you do press enter after you type everything. That'll give you all the rest of the buttons back. And then the last one will be negative 5x minus 20y plus 10z equals 13. So what I want you to do is put your system of equations into an augmented matrix, just like this one, and then row reduce it to find the answer. Once you think you've got it, type what you think x, y, and z are in the chat. And if you're having any issues with calculators, say something in the chat as well. Nice. Looks like we're getting it. Eduardo, I think something might have gone wrong on yours. Could have just been like the way you typed the matrix. Yes, I will go over it on Desmos once we're done here. All right, looks like most of us are getting the right answer here. So the matrix that we should have, the augmented matrix we should have chosen here was, if we have our x's here, we'd have 5, 2, negative 5. The y column would be negative 50, 10, and negative 20. The z column would be 1, 3, 10. And then the augmented part would be 24, 23, 13. So this should be the matrix that we type in. So I'll jump over and do this one on Desmos. For those of you working with a Desmos. We'll go new matrix. We want 3 rows and 2 columns. Then our top row is going to be 5. There you go, Eduardo, you got it. Negative 50, 1, 24. Then we should have 2, 10, 3, 23. And then negative 5, negative 20, 10, 13. And then we hit enter. And then we just click RREF. And then since this was matrix B, we type B. And that's the matrix we should end up with here. Okay, so the reduced echelon form of the matrix. We got our zeros and ones. Awesome, Jasmine. And when we got 5, 0.1, and 4, which tells us that x is 5, y is 0.1, and z is 4. Or as some of you wrote it, you could also write it as an ordered pair or ordered triple. So 5.14 would also work. Sorry, not 0.5, 0.1. Yikes. All right. So either way of representing your answer is totally fine. Okay. Any questions at this point? Okay, we'll do one last one. It's a 2x2, or 2 equations, 2 variables. But I do want to show you another way that things could show up for you guys. So it could be something that you're given like 4y equals 12x minus 3. And then like 9x equals 20y minus 2. So for this one, I just wanted to go over really quick that you would need to move all of your variables to the left-hand side first. So in order to put this into a matrix, you would want to subtract 12x from both sides first. And subtract 20y from both sides of this one first. And rewrite it as negative 12x plus 4y equals negative 3. And rewrite this as 9x minus 20y equals negative 2 before you start. Then it would be the same exact process as the other two that we just did, except you would only need a 2x3 matrix since it's a smaller one. So your augmented matrix would look like negative 12, 9, 4, negative 20, negative 3, negative 2. Okay, so that's also something that you might see. You just got to do a little bit of algebra before you do it. Okay, tonight's assignment is not going to be in IXL. So some of you are saying, thank goodness, I needed a break from IXL anyway. So we're going to jump over to Google Classroom. And not that, classwork. Okay, so today's is a worksheet instead. And the way it's going to work is the worksheet is a PDF. IXL kept kicking you out. That's a bummer. But yeah, so today's is a worksheet. There's specific instructions with each set of problems. 1, 2, and 3, all you have to do is take the augmented matrix and put it back into a system of equations. So write the system of equations that, that this came from. Then for 4, 5, and 6, you're going to do the opposite. You're going to make the equations into an augmented matrix. And then for 7, 8, and 9, you're going to do what we did in our examples. So you're going to put them into an augmented matrix, then row reduce them in your calculator, write down what the final row reduced matrix is, and then tell me what the values are for X, Y, and Z. And then the last one's a little bit of a challenge. I mean, it shouldn't be super duper challenging because it's already looks a lot like a matrix, but put this data into what you think it would look like as a matrix. Okay, if there's work to be shown, make sure you show your work and just show all parts of your answer, I guess, for these ones. And then once you're done with it, take a picture of it or make it into a PDF or anything like that. You can use your Chromebook or your phone camera to do that, and then upload it to the assignment in Google Classroom. Okay. Any questions about what we're supposed to do here? Okay. Then let's see. Class ends at, I keep forgetting, 1:45. So at 1:40, we'll come back together and do one last thing. And you guys have time to work right now. So go ahead and get started. I will be here. If you need any help, feel free to hop on and ask away.